Yes. So I'm going to turn it over to him. He has a lot of some really cool local stuff that he's going to talk about now.
Great job.
Okay, so I think something that all mobile phone vendors are trying to do now is if you run a local application, that application should be sandboxed in some way. So hopefully it won't be like the PC where if I run solitaire, then that solitaire application can totally own up the entire PC. We want to make it better. We want to be able to run solitaire and then not allow that solitaire application to access your email. So I'm going to talk about what happens if we write a malicious app and we get it on there, or what happens if we more likely find an injection bug in a third-party application that doesn't have access to talk to the private bus. How am I going to escalate my privileges and get access to sensitive data on the device? So really what I want to do is I want to find a way to go from my clock application to my email application. And I'm going to do this by exploiting the IPC mechanisms on the phone. So the way that different applications and the services communicate. Thankfully, there's a lot of local attack surface. And all these bugs, by the way, everything that we've talked about have been disclosed and fixed for quite some time. Anyway, when legitimately the one way that applications will communicate is that they'll use the application manager to launch other applications. So for example here, I want to launch a movie application and maybe look up movie times or something like that. And here you can see I talk to the application manager, and this is going to be the ID of the app I want to start, and then here are some parameters I'll pass to it. Okay, so there are no restrictions. Every app can launch every other app. And we have parameters, and the parameters are just JSON. And so what's the first thing you're going to do? Well, the parameters could be very malicious. They could contain JavaScript, so we could be looking to leverage other injection vulnerabilities, or they could exploit business logic issues. So the first vector is we'll actually launch another app. And this is the update application that we talked about earlier. And we'll send over JavaScript in the version parameter, right? That JavaScript is going to be what we call a Mojo stager. So it's a compact snippet of JavaScript. It's going to use the Mojo load script with callback method to refer to an external JavaScript file. That's our shellcode. And that shellcode is going to talk to the email service and basically read all the email out of the email and upload it to a remote service. So remember that email service I talked about in the very beginning is on the private bus. The email storage system, I can't send messages to it unless I'm a com.pom app. So what I did is I found a bug in a com.pom app, sent my JavaScript from my third-party application to that app, and then once my JavaScript is running, I then use those privileges to access the private bus and steal the email. Another interesting thing is WebOS applications are constructed very similarly to kind of a website. You'll have multiple scenes or basically multiple pages, and there'll be a stack of pages that you can either push or pop off of, right, to do your navigation. And so this is used in one way to give you privileges to stuff that you normally wouldn't have access to. So for example, if I want to take a picture, Palm does not allow you access to the camera control by default because they don't want you turning on the camera without the user's permission. So what you have to do is you have to push the com.pom camera application and say, take a picture for me and then give me back that data. And that's how I'm going to use the camera. So a legitimate cross-application push says, okay, push the scene from com.pom.app.camera, push the capture scene, and then pass some parameters to it. So once again, we could have parameter validation issues because the scenes could have arbitrary parameters. Some apps or some scenes don't realize or aren't written in such a way that they expect to be invoked cross-application. So say you have like, this makes more sense on the web, but you might have like a 4-stage purchase flow for a website. You put stuff in your cart, you review your cart, you do a checkout, you get confirmation. Okay, so how many bugs have been found where you skip the first 3 steps and you go straight to the confirmation page? And it didn't expect you to do that. It didn't expect you to pass bad parameters. Same problem here. you might have a multi-stage application, multi-scene application. Well, I'm not going to launch the first 2 scenes. I'm going to launch the 3rd scene. And the update bug was like this. But also another bug I found in the camera is you can pass parameters, and one of the parameters you can pass is like the file you want to write to. So we'll tell the phone to write to kernel memory when you take a picture. And obviously this isn't going to be like a remotely exploitable bug, but certainly the phone is going to reboot and blow up. And I think it's a promising area of research. So when you find a kernel exploit that you can trigger by taking a picture of something, please tell me, because that would be super cool. But anyway, so bugs like this, parameter validation bugs, are prevalent on WebOS because the documentation, frankly, is a little bit weak about how scenes can be launched and about the application lifecycle in regards to parameter validation and out-of-order invocation.
Does it actually run as is that actually a privileged process? Because normally
it's a com.pom.camera app.
It runs with essentially.
Yeah, and what it uses is it uses the NP API plugin that has access to the camera device. Right, so there's like a piece of native code that's the bridge between the JavaScript running in WebKit and the camera device to do the capture. And so that camera control has like a method that's like, here's the file name to write data to, please. And, right. Some other injection bugs that we found, I'm not going to go into too much detail. One is that sometimes you can pass JSON as a string. So you're not passing like an object, you're passing just the JSON as a string, and the remote guys are going to reevaluate that JSON to turn it back into an object, to rehydrate it from JSON to an object. And so when you pass that string, then you just pass some JavaScript that you wanted to evaluate when it rehydrates the object. And if they don't rehydrate the object using basically a special parameter, then that JavaScript will execute. Additionally, POM has basically a special HTML templating language, and that HTML templating language in the first versions of the phone didn't escape HTML or didn't escape user data when it was combined with the HTML. So guess what people didn't do? They didn't escape the data manually. Now by default it escapes data, but a lot of the legacy applications like the email, like the contacts, all the apps that were written when escaping HTML was the default, they turn off that feature. So they have to do it all manually. And so if you're reviewing code, what you want to look for is the magic minus sign that says, don't HTML escape this. One thing that we really want to point out is that we found a lot, there's basically like 3 different types of injections. You can get HTML injection. Depending on where you get the HTML injection, you might be able to launch documents or web pages without clicking. But you won't be able to execute JavaScript. Sometimes you can execute JavaScript, but you can't access Mojo. So that means that I can't do some of the cross-app launching attacks I talked about, because to do that, I need to be able to launch Mojo and basically, in order to send that message across process. And then lastly, you get Mojo, and that's, well, when you have Mojo, you have Mojo. And when you do that, then you have the ability to access all the phone services, and then that's how you're going to really jump across applications like I demonstrated. Now, I guess maybe the question would be, how do you tell the difference between the 3 bugs, or what is the protection system that makes it so in these different contexts, JavaScript or HTML doesn't work? I don't know. I'm still looking into that. I think that
we would find areas where you could do HTML and not JavaScript. We do JavaScript and not Mojo, and then it would just. We had to do further research in that area, but between the 2 of us, we haven't figured that out.
I actually came up with the idea that I think that some cool diffing to do might be, POM publishes their WebKit diffs. So I bet the answer lies in their WebKit diff, because that's probably how they configure the rendering to allow or disallow JavaScript. Anyway, that's my running theory. So, okay, how do you mitigate WebOS script injection? You buy a book on mitigating web attacks, and you validate input. You use, to stop the JSON, you have to pass eval JSON true. Don't forget the true. The true is very important. That's another good thing to look for when code auditing. Don't disable HTML escaping. And then, lastly, don't generate HTML using string concatenation. Use inner text, or use all the other bad web coding practices that we've talked about in the future. or in the past. I'll talk about it in the future.